Hello everyone, I'm Debashish from Dev's Learning Hub. So today we are going to start our fifth class on measures of central tendency. Already we have covered mean, median and mode part. In the first video I have covered the concept of mean, median, mode, and also I have covered how to determine mean and median both for ungrouped and grouped data, that is both for continuous and discontinuous data. In the last video, that is on class 4, also I have explained why these mean, median, mode, these are called the measures of central tendency. I have explained what are outliers, what is normally distributed data and what is skewed data, and for each of the kind of data distribution, which is the efficient mode of determining the nature of data distribution. Somewhere it is mean, median, mode, any of these three, somewhere it is only median, right? So today we are going to cover quartiles, that is another measure of central tendency. So I am going to explain today what is quartile, what is the usage of quartile, why do we need to understand quartile, and how to identify outliers using quartile. So outliers you understood from the fourth class itself, and real life example where quartile is used very much. So what I will advise you to look into the first class, particularly the first class, to understand mean, median and mode concept, and the fourth class also where I have explained normal distribution, skewed data, and why these are called central measures of central tendency. So that is for your understanding. Not necessarily everything will be coming into your exam, but that will give you the overall understanding of these measures of central tendency. And going forward, whoever will is also studying AI and also will study in standard 11 and 12 AI ML, that is a artificial intelligence and machine learning, there also these mean, median, mode, quartile, these are very important terms, and you need to understand for the pre-processing of data, that is for data analysis, right? So what is actually quartile? Quartile is if you divide the entire set of observations, the number of observations, into 4 equal parts. If you divide the entire set of observations into 4 equal parts with respect to the number of observation, then each part will have equal number of observations. So let's say total number of observations, if I say n, in that case each of the part it will have n by 4 numbers. Right? So this n by 4, end of first quarter, n by 4. So this is first and foremost thing for quartile is you need to arrange the observation values in ascending order. So let's assume this is the lowermost value, this is the highest value. So end of first quarter, it is called first quartile or Q1. This is end of second quarter, that is Q2 or second quartile. This end of third quarter, first one, second one, third one. So third quarter, that is called Q3 or third quartile. Q1 also termed as lower quartile or first quartile. Q2, if you see, this is second quarter. Second quartile means n by 4 plus n by 4. That means n by 4 into 2. n by 4 into 2, that means it is n by 2. So n by 2, that means Q2 is the median. So n by 2 means that is 50% of the total number of observations, n, 50% of n. So Q2, the second quartile, is also called median. And Q3, that is the third quartile, it is termed as also upper quartile, right? So with respect to the number of observations, First quarter, it is having at the end of n by 4. So first quartile is n by 4. Second quartile, that is the median, that is n by 4 into 2, that is equals to n by 2th term. Third quartile is n by 4, n by 4, n by 4. That means 3 into n by 4. So with respect to now percentage of data, if we consider the total number of observation n, and that is equals to n is the 100%, then first one is 25% of data. Above Q1 it is 25%, Q1 to Q2 that is another 25%, Q2 to Q3 that is also 25%, and Q3 to above Q3 that is also 25%. So below Q1 25%, above Q3 25%. Right. So now if we see the first quartile, actually it is the 25% of data, or 25th percentile is Q1, Q2 is 50th percentile or median, Q3 is 25 plus 25 plus 25, that's the 75th percentile or 75% data below Q3. Above Q3 another 25% data. So if you are asked to find out the upper quartile or the third quartile, that is actually the 75th percentile of the entire data, right? So Q1 is termed as first quartile, but first thing you need to remember, like median, for determining quartile, first of all you need to arrange all the observation values in ascending order. For median you can arrange either ascending or descending order, but for quartile you should arrange all the orders into all the observation values in ascending order. Then only we are assuming Q1 is the lower quartile, because we are considering the leftmost observation values as the least one and the rightmost observation value is the highest one, right? Now if we plot this as a box, let me show you. So let's say in this box plot diagram, it is box plot, horizontal box plot. So it is the lowest one, it is the highest one with respect to observation value, right? So 4 quartiles, right? Q1, Q2, Q3. Q2 is the median, first quartile, third quartile. Now from this Q1 to Q3, so Q1 to Q2 it is 25% data, and Q2 to Q3 it is 25% of data. That means from Q1 to Q3 it is 25% plus 25%, altogether 50%. This Q1 to Q3, that is Q3 minus Q1, this portion, it consists of 50% of data, or it is called quartile division or inter quartile range, IQR. So IQR equals to, if you know the value of Q3, third quartile or the upper quartile, and the first quartile or lower quartile, you can identify the inter quartile range, that is IQR, which IQR is Q3 minus Q1. So that means IQR, inter quartile range, this is how to determine inter quartile range. That is the difference between third quartile minus third quartile and first quartile, right? So this inter quartile range, this consists of 50% of data. So inter quartile range, it consists of 50% data. Actually, why you need IQR, that you will understand later on. Let me go through the video, then you will understand what is the usage of IQR. But IQR also determine the spread of the data between Q1 and Q3. Okay, now you understand the concept. I am giving one example how to determine Q1, Q2, Q3 and IQR. Understand the concept, don't go by any formula. Okay, so these are ungrouped data or discontinuous data. right? So what is your first task to determine quartile? First, you need to arrange all the observation values. These are the observation values. You need to arrange all the observation values into ascending order. So let me do that first. So after arranging the observation values in ascending order, that's how it looks like 7, 9, 11, 13, 15, 17, 19. Now first, to determine the median, first you determine the median, and then you will determine Q1 and Q3. So first, to determine the median, how to determine median? Number of observations in equals to, here it is 7. So if the number of because median is the positional value, right? First you need to determine which position is the median, does have the median. Median is having 50%, so 50% of data, right? So if median, the number of observation is 7, that is the odd number, that means the position for median, it will be n plus 1 by 2, that is equals to fourth position. 7 plus 1, 8, 8 by 2, that is the fourth position. So median or Q2, median is the Q2, median or Q2, that is the fourth observation value. So fourth observation for this ordered data set is 13. That means 13 is the median, or it is Q2. Q2 and median is same, so 13. Now, once you determine the median and which position the median it is there, fourth observation. That means you have 3 data set both sides, because if it is the fourth observation, that means you have 3 data set at the left side of the median, that is at the side of Q1. And if you, since you are dividing the entire data set into 4 equal parts, if you have 3 data set before the median, you will have automatically 3 data set also after the median, right? So 3 observations if you have before median, then you need to find out the another median at the left side, which is Q1, because Q1 is the median of the least value and median Q2, and Q3 is the median of Q2 and the highest observation value, right? So Q1 will be the median. So fourth observation is the median. That means you have 3 data set at the left side of the median and right side of median. So at the left side of median, if you have 3 data set, again to find out the median, observation, number of observation is 3, means you need to find out the median by having n plus 1 by 2, that is 3 plus 1 by 2. 3 plus 1 by 2, that is the second position from left. Second position from left means it is 9. So 9 is the Q1. Nine is Q1. Equally, Q3. So right side of the median will also have, the median will be at the second position from the median, right? Because the right side also you have 3 data set. So if it is the number of observation at the right side of median, it is odd number. That means what will be the median? 3 plus 1 by 2. The second position from median, right? So second position from Q2, or Q2 is at fourth position, that is the 6th position from left. Either second position from Q2 or fourth observation is median Q2, 6th observation from the left, that is Q3. So second position from Q2 or 6th observation. 6th observation means 1, 2, 3, 4, 5, 6, that is 17, or second position from Q2, first and second. So you need to exclude the median, right? Then you need to determine what are the number of observation you are left with at the left side of the median and right side of the median. So 17 is the Q3, second position from Q2. This is what Q3. Understand the concept, automatically you will be able to solve any problem. That is Q3. So now Q1 is 9, Q2 is 13, Q3 is 17. Now you know what is Q3, what is Q1. So now Inter Quartile Range. What is it? Q3 minus Q1. This area. Q3 minus Q1. Q3 is 17. Q3 minus Q1, that is equals to 17 minus 9 equals to 8. So IQR is 8. Now, so the results are, I have written out here. So Q2, the median is 13. Q1, that is the first quartile or lower quartile, is 9. Q3, that is the third quartile of the upper quartile, that is 17. IQR, that is the interquartile range, that is 8. Okay, so now I will show you what is the usage of IQR actually, statistically or with respect to data. Outlier already you understood in the earlier video. What is outlier actually? Still I am saying, in a given observation values, if there are any extreme values, either in with the highest, with respect to the highest value that is much higher than the highest value in this observation, or is much lower. So let's say there is one value 50. So if you see 7, 9, 11, 13, 15, 17, 19, suddenly 50 is, it is out of the, extremely high value. So whether it's an outlier or not. So first we can see, we can visualize, we are saying probably it's an outlier. But actually, exactly, if you need to understand above which value or below which value the outlier is there, you need to utilize this interquartile range or IQR. How to do that? The formula is so either outlier could be extremely low or outlier could be extremely high. If it is extremely low, that means it will be below Q1, and if it is extremely high, it will be above Q3, third quartile. So when it is extremely low, what is the measurement? Q1 minus 1.5 IQR. If the value is below Q1 minus 1.5 IQR, that is the border value for the lower outlier. And higher side outlier, what is the value? The extreme value, that is the limiting factor, that is Q3 plus 1.5 IQR. That means if it is above Q3 and the value is more than Q3 plus 1.5 IQR, this is extremely high. The value is extremely high, and if you look into this, the previous video class 5, then previous video, that is the class number 4, there you will see if the outlier is towards the positive direction, extremely high, then it will be positively skewed data. And if it is below, much below to Q1, that is Q1 minus 1.5 IQR, then it will be negatively skewed data. Okay, so here if we see there is one point, so first you understand based on this Q1 and Q3 value, IQR values, and Q1, Q3 and IQR, what is the limiting factor or the boundary for outlier? For lower outlier, lower side, Q1 minus 1.5 IQR, that is equals to Q1 is 9 minus 1.5 into IQR is 8. So 9 minus 12, that is equals to minus 3. And another value is, so this is one borderline value, for outlier, and another borderline value is Q3 plus 1.5 IQR, that is equals to, what is the value of Q3? 17. 17 plus 1.5 into 8, that is 17 plus 12, that is equals to 29. This is another borderline value for outlier. That means if in this particular data set, if there is any value which is less than -3 or greater than 29, then this will be treated as outlier. So if we say 50, there is one value, then definitely that is an outlier, because any value beyond 29 above 29, that will be treated as an outlier for this set of observation values. And any value that is below -3, that will be also treated as the outlier, but in the negative direction for negatively skewed data, and again with respect to this set of observation values. Why I am saying with respect to this set of observation values? Because you have determined Q1, Q3, IQR with respect to this set of values only. Right? So your outlier set, it depends on the given set of values. Now, if you look into my earlier video, class 4, you will come to know that to understand the actual data distribution, always it is advisable to eliminate the outlier. What is the objective of identifying the outliers? To understand the majority data distribution, outlier doesn't give the picture. So therefore, it is always advisable to identify the outliers and remove those outliers from the given data set to understand the actual data distribution with respect to the majority data set. Got it? So that is the utility of, one of the utility of IQR, to determine outlier. There is one more utility. If the IQR range, IQR value is very low, that means this 50% of data set in the IQR, that is the variability of the data set is very low. And if that means it's a more consistent data. And if the IQR is very high, that means the variability within this 50% data set is very high. So it is a dispersed kind of data. Okay, so that is the purpose of determining IQR. Okay, now utility of quartile. We know mean, median, mode. What is the utility of quartile again? Quartile, already I have explained just now how to identify outliers using IQR, Q1 and Q3. So outliers, identifying outliers is one of the most important usage of quartile, because eliminating outlier is a crucial step for data pre-processing while you are doing data analysis, or just for your understanding now. Don't you understand about data science, data analysis, or AIML? Because AIML, that is there in your class 9 and 10 chapter also, but if you didn't go through that part still, so probably you will not understand about the data analysis part. So outlier, already I have explained in my earlier video how outliers impact the entire data distribution. So just understand that removing the outliers gives the more effective picture of the actual data distribution, because just a few very high or very low values, if it impact the mean, which actually happens, because outlier impacts the mean heavily. So when there are outliers, it's better to remove the outliers and check the data distribution, actually how it is for the majority set of data. Second is understanding data distribution and spread. Spread means in the IQR, what we have shown in the IQR, if it is Q1, this is Q3, and this one is Q2. So Q3 minus Q, this is 1, this is IQR. So as I said, this IQR, if the value of IQR is very low, or that means the variability, because this IQR, it consists of 50% of data. So if IQR value is low, that means majority of the data set are nearby or most similar in nature. So those are consistent data. But if the IQR value is very high, that means the data variability that is high. That means the 50%, within 50% data set also, there are a lot of variability. So that is one part, to identify the spread and the data distribution also, because in the first quartile, in the above the third quartile, below the first quartile, so what is the, how the data distribution it is there. You will understand in the real life example when I will explain it by giving one or a couple of examples, what is the usage of quartile also by having the picture of data distribution, and there why you need the quartile. Okay. Third one is more efficient measure for skewed data. Since quartile also is a positional data reference like median, and you know very well that mean is heavily impacted while there is presence of outlier or the skewed data. Because mean is considering all the data set, taking the average of those. Therefore, any extremely high value or extremely low value impact the mean heavily, whereas since median and outlier, you need to identify. So since it's median data, positional reference you have, not considering all the observation values directly, it's the position of the data. Therefore, it has very minimal impact or no impact. No impact I cannot say, minimal impact while there is a presence of outliers. So for skewed data like median and quartile both are efficient measure for skewed data, not mean. Okay, so these three are the most important utility of quartile. Now I will give you a couple of examples for real life example using quartile. Okay, before coming to the real life example, let me tell you one thing. Just sometimes you can straight away use the formula because you understood the basic concept, how to determine what is quartile and how to determine quartile. But for a huge number of values, sometimes you need to use the formula also. So if there are, we have seen that if this is the data set and we have divided it in 4 equal parts, it is Q1, it is Q2, it is Q3. Q1 is having n by 4, Q2 is n by 2, and Q3 is automatically, because all the portions are equal, because 4 equal parts, all the portions are equal. That means Q3 will be 3 of Q1. Q3 equals to 3 times of Q1, that is, because Q1 equals to n by 4, that means Q3 will be 3n by 4. If this total number of observation, this n is odd, that means here, there your Q1 will be n plus 1 by 4. And Q3 will be 3 times of n plus 1 by 4. 3 times of n plus 1 by 4 when n is odd. When n is odd. So, n by 4, n by 2, 3n by 4 for even number of terms, but for odd number of terms it is n plus 1 by 4. For Q1 and for Q3 it is 3n plus 1 by 4. It is the position of the quartile. Right? Then you will find out the value at that position from the given values, observation values. Right? Now, understand here. Real life example, there are few test scores are given for the students. 55, 60, 65, 70, 55 is the lowest. I have already arranged all the numbers in the ascending order. So 55 is the lowest number, 98 is the highest number out of 100. These are the numbers out of total score 100 out of 100. 55 is the lowest score and 98 is the highest score. Now the question is given, find out the top 25 percentile, top 25 high performing students. They are defined the top 25% students. That means top 25% scores you need to identify, and those students who has achieved those scores, they are high performing students, right? So let me write down the question. So what is the top 25% student scores? High performing, those are actually high performing students that you need to identify from here. So now, if I again just give this graph, this is the lowest one, let's say L equals to 55, and this is the highest one, that is H equals to 98. This is Q1, this is Q3, and this one is Q2. Now, if it is top 25% means your Q1 is bottom 20%, Q1 is 25%, and Q3, that is 75%. That means above Q3, whatever scores will be there above Q3, you need to determine which is the Q3, and whatever scores beyond that point, those are actually high performing scores. That means the students, those have achieved those scores, they are high performing students, right? So you need to find out the value of Q3, and also you need to find out bottom 25% student, below performance, right? So there are two questions. Identify the high performing students, that is the top 25% student scores, and the bottommost 25% students. So when it is asking bottommost 25% students, that means you need to find out the value of Q1. So here, what is the number of scores it is given? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 15. So n equals to total number of observation, it is 15. Since n is odd, we know that for Q1, the value of Q1 will be n plus 1 by 4. When n is odd, total number of observation is odd, Q will be n plus 1 by 4. So which position data? That is 15 plus 1 by 4 equals to 16 by 4. That is the fourth position. Fourth positional data. That is actually 1, 2, 3, 4. This 70 is Q1. 70 is Q1. What is the value of Q3? Why you need to find out Q3? Because the top 25%, these are bottommost 25%. So those have scored below 70, those come under the bottommost 25% students. So because 25%, that is actually the borderline of that is the point Q1. So below Q1, that is the first 25%, because this is the first 25% before Q1. This is the second 25%. This is the third 25%, and this is the last 25%, that is above Q3. This 25% is below Q1. This 25% is above Q3. So those are, if you identify the Q1, this is the marks at Q1, that is 70. So below 70, that is the 55, 60, 70. These are actually the bottommost 25% students. These 55, 60, those have achieved these scores, those are bottommost performing students, right? So bottommost students scored below 70, here it is 55, 60, 65, whatever number it will come here, right? So 55, 60, 65, okay? Now you need to, this is the question number 2. Now question number 1. Question number 1 is top 25%. That means you need to find out Q3, and then above that score, that will, the students those have achieved the scores above Q3, those are actually high performing students, top 25% students, right? So Q3, so since n is odd, in that case Q3 will be, we have said Q1 is n plus 1 by 4, so Q3 is 3 times of Q1, so 3 into n plus 1 by 4, that means 3 into 15 plus 1 by 4, 16, there is a 12th term, or 12th position. So what is the 12th position? It is the 15, just back calculation, 15, 14, 13, 12, 90. 90, those are 90 is Q3, value of Q3. Now, students, those have scored above 90, that means here it is 92, 95 and 98. The students, those have scored these 92, 95, 98, those are high performing students. These are the scores of high performing students, right? So, top 25% or high performing students scored above 90. So, above Q3. That here it is 92, 95, 98. Those are the scores of high performing students. Right? So, that is all about quartile. Here I have, I believe you have understood what is quartile, what is the utility of quartile, what is IQR Inter Quartile Range, and how to identify outliers using quartile and real life example. This kind of things you can utilize. This for the education sector, right? Now you can utilize also this kind of data set using quartile. Let's say the revenue is given for few quarters. So which quarter is performing at the top 25%? Or let's say sometimes you receive reward, right? Reward based on your or offer, any kind of offer, when you are purchasing online at Amazon or any retail shop, or you are utilizing GPay very much. So the spending, you are using GPay for maximum spending. So they are awarding their customers based on top 25% customer, based on their investment or based on their spending, nature of spending. So there also you can they segment the customers based on this quartile. Who is those are the customers, those are using bottommost 25% customer, those need extra attention, those are spending less, or those are not utilizing the site, or those are not utilizing that app. So concentrate on those customers and get them back. And top 25% customers, those are spending very much or spending really high. So they will give a borderline, so top 25%, they will not give any value as such. Top 20%, 25% rewarded, bottommost 25% need extra attention. Even though for any kind of organization for salary upgrade, right? So what is the top 25%? What is the bottommost 25%? What is the average? 50%. There's the IQR, Inter Quartile Range. Based on they decide the salary upgradation. So there are a lot of real life example where basically quartile is used, because quartile gives the picture of data distribution or the values and each of the quartile itself. That gives better understanding of the data distribution, right? So I hope you liked it, and if you have liked it, please click on the like button, and if you would like to have this kind of video again and again, please subscribe my channel. Thank you very much.